speaking.
Yeah,
Okay. And if you cannot hear me at any point, it's well to please draw my attention.
no problem.
So CAD stands for computer aided design. It's simply using, like the name implies, simply using the computer to make design easier. Before the invention of CAD drawings, we used to draw on paper. CAD doesn't necessarily replace those paper drawings. It just makes it easier because paper drawings are still rampant. So 2D drawings are the basics, because if you don't properly understand 2D drawings, then you would have issues interpreting going over to 3D and interpreting the drawings you meet in the industry, because most of them are still 2D. You might see 3D just to have a general idea, but interpreting this drawing, you need very good knowledge of 2D drawings. And to help you in any field, not just engineering. So why does it matter? It's because of standards. These standards are set to unify communication methods, just like all the rules of English language. That's why the standards of drawing matters. Any drawing, if you do a drawing, it should be someone from someone from another part of the world should be able to interpret your drawing. That's why we need to follow these standards in drawing. Okay, this is the difference between 3D models. Typically, 3D models are not deliverable products. Most companies still rely on dimension, tolerance, and complete 2D drawings for production. Paperless processes exist, but are a long way from being standardized. For many things, 3D models are just simplified means to create 2D drawings. What we are saying is, when you get to the company, or in most companies, they still use 2D drawings. You don't just send a 3D drawing of a building to the engineer on the site and you expect him to produce that building. It's the 3D drawings that you see the dimensions and the positioning of every feature in the building, and that's how he'll be able to interpret it properly, or to reproduce it, not interpret it. If you see the 3D picture, sorry, are you still there?
I'm there.
Okay, once you see the 3D picture, you'll be able to understand it, but to reproduce that same drawing, you would need dimensioned 2D drawings for reproduction. If you're working with just 3D, you'll not be able to introduce it exactly how it is. So a solid understanding of CAD has little value without a stronger understanding of 2D drawings. It's like I said, this is the basics, 2D drawings. That's why we're starting from here before we move on to 3D. Because if you don't understand the 2D drawings properly, you would have issues along the way. So engineering drawings are complicated and require a set of rules, terms, and symbols that everyone can understand and use. Nothing is up for interpretation. That's why there are these bodies like American Society of Mechanical Engineering. There's also ISO and some other bodies that brings up these rules and things that we use for the drawings. Different countries have their own different. Some countries have different bodies. So once you follow their set out rules, you'll be able to understand and interpret any of these drawings. There's this ISO, International Organization for Standardization. It sets the worldwide standards. The ASME it's an American body, although some companies draw with their standard, it's still acceptable as far as you indicate it. So engineering or technical drawings furnish a description of the shape, size, features, and precision of physical objects. Other information needed for construction is given in a way that is easily recognizable to anyone with engineering drawings. Primary drawings are used when designing onshore or offshore components, and that's what we're going to focus on in this class. But the knowledge, you can apply the same knowledge to almost every other branch of engineering, really, like civil engineering, electrical, mechanical, architecture. If you understand these 2D drawings, you'll be able to look at a building plan and understand most of what is there, even if that's not your field. But 2D drawing, it's like we said, it's a standard that once you understand it, you'll be able to read almost every other type of drawing there is, as far as it's in 2D. So there are pictorial drawings. These ones are similar to photographs. They show objects how they will appear to the eye of the observer. When you see a pictorial drawing, they try to represent the drawing how the viewer is seeing it. So they are mostly not used for technical designs, because some of these complicated features and details, they will be easier to understand when they are dimensioned. There are 3 types of this pictorial drawing. The first is oblique. Sorry, are you still there? Are you lost?
I'm there. I'm with you. Yeah.
You understand everything I've said so far?
Yeah, I do. This noise, can we help it? I don't know.
Are you still? It's still noisy.
Yes, from the beginning, it's still noisy.
Sorry, is the noise coming from my end? Because I'm actually muted.
Okay, you muted your side.
Yes, I'm muted. I just unmute myself now. So I think only the trainer should unmute himself. Then you can probably mute and unmute to communicate with him. I think that was better. Thank you.
See the same thing. No worry. Let's go ahead. Let's see the same thing. Let's go. All right, let's go ahead.
Okay. Is the noise still there?
No, don't worry. Just go ahead. I still hear you. It's okay.
Okay. So there are 3 types of pictorial view, like I said. The first one is oblique. It's the images are drawn at an angle of 45 degrees. It's just like it's shown here. So the front view, the top and the side. Then the second one is the perspective view. The objects get smaller as the distance increases. So with this, you hear terms like the vanishing points, where the object gets very small. And so, like I said earlier, the pictorial drawings are just they're drawing it with, like, how the observer sees it, and they are mostly not used for technical drawings. Then the third one is isometric. This is a more popular one. It has the 30, 60, and 90-degree lines. We sometimes, amongst the 3 I mentioned, this one is used the most, but it's still not. It's used sometimes to show to give a better view of or a better understanding of what the object looks like. So sometimes we put it in isometric view. So especially when we're explaining to non-technical persons, so someone that should just look at it and understand what it is. And some people use it as some people use it when they don't want to use a 3D drawing. Sometimes they use it interchangeably with 3D drawings. But these are still under pictorial drawings. The ones that are used now for technical drawings are orthographic projection. So I'll spend more time explaining this. Orthographic projection. I don't know if are you familiar with the term? Hello?
Come again.
I'm asking if you're familiar with this now. Orthographic projection.
I am. I actually did all this in school. So.
Oh, okay. So it means I will not.
No. Assume no experience. Assume no experience.
Yes, I know. Just continue.
Yes.
I better understand what
I'll still explain it. I just wanted to know if okay, let me just go on. So orthographic projection, we use it to show the hidden and the visible parts. So typically where there's the front view, the top view, and the right side view. And in orthographic projection, the most commonly used one is the third angle projection. And this arrangement that is shown here is how the third angle projection is top view up, front view just below it, and then the side view. So if you can, let me zoom this so that you see it properly. The image here, this is the top view. So if you're looking at the top of this now, if you're looking from the top, you would see this first box. That's what's shown here. You would also see this. These are the only faces you would see. If you're looking from the top, you see just 3 faces. This face, you see this other face, and you see this other face.
All right.
So you understand that, right?
I do.
All right. So that's what's shown here now. This first face. This face is this, and then this is this. Then if you're looking from the front, you'll see 3 faces also. You see this face here, you see this other face, and you see this face. You're not going to see this face again if you're looking from this front view. You will not see this face, you will not see these other faces. You'll see just this 3, and that's also what's shown here. And if you're looking from the side, you'll see just 2 faces. You'll see this face here, and you'll see this face. So are you following?
I'm with you. Yeah.
You understand, right?
Clearly.
Okay. So orthographic projections, they are essential to understanding and visualizing objects. Principles can be applied in 4 angles or systems, but the 2 commonly used ones are first angle and third angle. The difference between these 2 now, first angle and third angle, is the arrangements. For third angle, we show the plan or the top view first, then the front, and then the side, like this. This is third angle projection. What was shown here was third angle projection. But first angle, the front and the top, there's usually a switch between the positions of the front and the top view. So the third angle is the more commonly used one. It's used almost exclusively on all mechanical drawings. 3 views are usually sufficient: top, front, and side. Sometimes in circular objects, sometimes you see people use just two views, because most often, or in some circular an example is a cone, a cylinder. With the way a cylinder is, with the way a cylinder is, I'm trying to make a very rough sketch of. You know how the shape of the cylinder is. So if you're viewing a cylinder, if you're trying to convert this cylinder to orthographic view, you would see, looking at it from here, you see, assuming this is your top view, your front view, you'd see just this as the top view. Now if this is your front view, you see this as the top view, which is this part of the cylinder. Am I right?
Yes.
Then you would also see something like this as the front view. In this case now, most often, sometimes we don't go as far as putting the additional side view, because that will just be the same thing as the front view. I don't know if you understand.
I understand clearly.
Okay. So in some cases like this, you see only two views, but most often you'll see the tray views complete in orthographic view. Sometimes you'll see more than tray views also. In some cases, you'll see up to 4. Sometimes you'll see the top, front, right side, and left side. You can go as far as putting 6, but we try as much as we can to put only the necessary parts. We don't put parts that are, we don't end up we try not to put, we avoid putting different views just to make the work bogus. So if there's any repetition, if it can be understood by just 3 sides, then we make do with that. If you need an extra side for proper understanding, then you should go ahead and put it. But we know that the 6 views there are top, front, right, left, back, and bottom. Yes, it can be properly explained in this example. Imagine this object enclosed in a glass, and each part you see represents one view. This part is the front view, this is the top, this is the right side. If you're looking from this other side, that will be the left hand side. This is the back view, and if you're looking from this side, that will be the bottom view. But most often these 3 views are enough for proper understanding or representation of the objects. So this is still the third angle projection. This is representing it in these 3 views like I mentioned earlier. And these are the 6 views I said: the back view, the right, the left, the bottom, top, and front. So when you see a drawing, we try to show if we are putting it in, if we are working with first angle or third angle by these symbols. If you see this symbol here, you know that they are working with first angle, so it will help you read it properly. If you see this other symbol, you will know they're working with third angle. It's not right to just assume that third angle is the most commonly used, and so every drawing you see is in third angle. It's good, it's proper practice to check to see if the draftsman puts the view he's working with. So if you check and you see this now, you know it's third angle. And if you see this, and these symbols are usually located at the title block of the drawing. The title block it shows details of the drawing, not just this. It shows the scale the person drew on, the units, the title of the drawing, and some other information. So I would like us to just to be okay. So these are the this is what you would submit. This is the practice. But I'd like you to do at least one in the class just to make sure you understand it here. Just this first one. If you have a pen and piece of paper, to try to sketch out one of these views.
Okay. Should
For
I put on the video for you to see?
yes, you can. Yes, yes. You can work with either C or D, whichever one you want.
Okay.
Now they've given two views.
Mm.
What you should do is to produce the third one.
Okay.
So which one are you going to work with?
Anyone, I'm okay with anyone.
Okay, work with D then.
Okay. Let me put on my video. So.
All right. This now.
Huh?
This now. I scrolled down so you see the
Yes,
symbol at the
I've
end.
seen. Yes. Mm.
So you know that this represents what angle projection.
Yeah. So just
No, I'm
to,
asking. This is
I've seen it here. That is the third angle.
okay.
Mm. Okay. All right.
Oh, I guess I need to stop sharing before I'll be able to see. Okay, no.
Oh, I need to see the figure.
All right, all right.
Mm. Okay. So I have. Uh, All right. That's my sketch. I don't know if you can see it.
Hey, if you place it on the I can see it, but that's not quite. Uh, yes, yes, I can see it, but which one did you work with?
It is C I work with.
Oh, okay, okay. I thought you were working with D.
Oh,
Okay,
it is.
okay. Please let me see it again. Okay. Yes, yes, yes. That's it. Yes. So very good. So the others. So that was it.
Okay.
So the others, I guess. I don't know. Would you want to work on this now? You're required to produce like 3 different sketches. The orthographic projection rather.
Okay.
So which one would you want to use?
Anyone? Can you remove that black shade, please?
Yes, I've shifted it to the
Okay. let me go with anyone. I think any of them is okay.
Okay. So just let me know the one you're working on.
Okay. Let me do the A.
Okay.
So if I do the A, I have one, two, three, four. This one. So that's my top view. Sorry. Okay, sorry for the mix-up on the paper. Okay.
No,
Yeah.
no problem, my friend.
Can you see it now? Do
Yes.
the A. So
Yes.
this is my top view.
Yes.
This
Yes,
is my front view.
Yes. And
And
you're
this my
right. Yes, I've seen them. Yes, very good. Very good. Yeah, that's it. So,
sorry, let me get the paper.
all right.
Okay.
This one they want. What they're asking is to complete the drawings.
Yeah, to just introduce the drawing.
They just reproduce the drawing from the orthographic views, but they've already given this,
Yes.
which is easier to use.
Yes.
So just to draw it in proper isometric view.
So I should
They've
do
already
one.
Yes, you can do this A also.
Okay.
They've already started it.
Mm.
Better, so it's-
Okay, sorry, it's not to scale, but I think we can,
No.
manage it.
All right. All right. Yes. Yeah. Yeah, that's okay. So go back to the main. So let's move on. Working drawings. Working drawings now, they contain the complete information for assembly construction of a product or object. They are classified under three headings: the shape, dimensioning, and specifications. So we'll deal with them one after the other. But working drawings now, when an architect finishes his drawing, or a structural engineer, when he finishes drawing, what he submits or what is expected to submit is the working drawing. The working drawing is like the complete information where the working drawing is made in such a way that if I have the working drawing, I should be able to not just interpret the drawing but also reproduce the drawing. It means it should have all the information for me to be able to reproduce it. If you give a drawing and you don't tell them the dimension, that's not complete information. They don't know if you're working in millimeter or meter or inch or feet. If you don't tell them the materials you use, that's still not complete. So it should be a complete drawing in such a way that the person handling the drawing should be able to reproduce whatever you drew there and recreate it. So you should have all the information it needs to do that. Let's talk about lines. There are different types of lines. The first one is the visible line. They are usually used to indicate edges and corners of an object. It's like all the drawings you did and showed me, you made use of visible lines. None required hidden lines. Visible lines, they are used for the edges here. They should stand out clearly in contrast to other lines. Then the next one is the hidden line. They are used to show the parts that cannot be seen from that particular view. It's like if there's okay, this explains it properly. This is an object now. If you're looking at this from the front view, you'd see only this face. Am I right?
Yes.
So if I'm to draw this object, if you're drawing just the face you're seeing, you might end up drawing just something like this and submit because that's the face you're seeing. But it's not exactly right to draw just something, just that rectangle and submit, because it's proper to go further to show the hidden line here, showing that there's a part of the image that was cut, showing that there's a part of the image that was cut. This should be a dotted lines. It should not be a continuous line. So if you draw just that face, it will not, the person looking at the drawing may not truly understand it. It should be something like this now. There should be dashed lines there, showing that there's a part of the object that is cut somewhere that is not available. That this part of this dashed line is just showing that it's not available in the particular view you're looking at it from. If you look at it from maybe the side view, then you'll be able to see why this dotted line was there. Do you understand?
I understand you.
Okay. So they illustrate features such as lines and holes that cannot be seen from the outside of the piece. Okay, this and that practice now. To match the orthographic drawings.
With the isometric.
Yes. So
Choose one.
Okay. Let me do one first. Okay, I can already see that E matches with number 1.
Okay. So which one do I choose? Do I identify?
Yeah, look for the one that matches with number 2.
Number 2. Okay. I'm serious. I'm not. Let me do it. Are they all matched? Are they all matched?
Yes, they are. Okay, number 3. I've seen why
The two
this
is
number
not
2 might be an issue. So just move on to number 3.
okay. Better. At least just saying. Okay, let me just see that number 3. Okay, number 3 is I'm seeing okay, let me see this one. One is here, yeah. Okay, number 3 seems like C.
Okay.
I have okay, C is looking like okay, let me see. Sorry, let me see something. No, it's not C, please.
No, yes, no, it's not C.
It's not C, it's not C. I'm seeing a F. F is there. Yes. Okay. F. Yes, it's F.
Yes, exactly.
It's F. Yes. Sorry about that. It's F.
No, no problem.
I just use only one view to see how I can. So
Uh,
I said, let me verify with the second view. Sorry.
that's,
Yeah.
when you go to the
The
front
second,
view,
yeah.
you know that
Exactly.
it's not C.
Told me it's not. Yes. So, yeah. So why is the
All
number
right.
two? Why is the number 2 challenging to identify there?
Oh, the number 2 is because the representation, the um number 2 is supposed to be H, but the
Okay, the way they
yes, the orientation of the image
even if it is
is
H, you see that it's not the top view is not clear H.
yes. That's why I just said
Yeah.
we
So
should move on.
mm,
This should have been the arrow should have been pointing this other way, like this, for it to be here. The direction of the
okay.
arrow is here. So
Yes.
the front view should be this,
Mhm.
and other view this. All right.
Exactly.
So the different types of lines. There's a circular line. We remember we've talked about the visible. We've talked about the hidden. Now this is the circular line. They're usually drawn as thin broken lines of alternating long and short dashes, and they're used to indicate the center points, axis of cylinder path, and axis of symmetry. So they use it when it's the center, or to show that two objects are symmetrical. That's where you see this line. And like they said, they are thin broken lines of alternating long and short. One is very long, then the other one is short, then very long, then short. So they are alternating like that. That's how it's drawn. Very long, short. Used to show center and all that. So circular features. Circular features, they appear circular in only one view. No line is used to indicate where a curved surface meets a flat surface. Hidden circles represented by hidden and center lines. We'll talk more of this when we go to counter bore and countersink. I'll bring this up again. And this is especially used when to show that there's a. We use this mostly to represent bolts and nuts, like provisions for bolts and nuts in an object. Yeah. So in order to show the dimensioning of that, we use this counter bore or countersink. But like I said, yeah, this is how it's shown, and this what they're trying to represent by it. This is countersunk, but when we get there, I'll explain properly. Often, only two views required for circular or cylindrical parts. Okay, this is what I was explaining, that sometimes in some drawings there you can have some drawings that only 2 views are necessary, like a cylinder, only 2 views. You don't need a 3rd view for that because that's over dimensioned. Okay, these are examples of circular views. This is what I mean by only 2 views. You don't need 3 views for this to represent this. These objects too, you don't need 3 views to represent this. These 2 views are enough. So sometimes we check when we are we don't just add all these views to make the work bogus. We only add the necessary ones. So how many views or sheets are required? As many as necessary to show all the features, sections, details, and dimensions to fully explain the path and tolerance is required to make it. Some simple parts can take many sheets with dozens of views to ensure complete definition. A rule I use is, after when I'm making my drawing sheets, I try to look at it and make sure someone else does. It's very common if you're the one making the drawing, it's very common to just assume that another party would understand what you mean, but you should be thorough with this. This is very, very necessary. Understand that your working drawing should have all the complete information. It should be such that someone else that did not go through the same design process to come up with that design, he or she should be able to look at the document and understand and reproduce it. So I will not start talking about design process now, but once you've come up with your design or coming up with your design, you might end up making a couple of rough sketches and a couple of adjustments here and there. But once you've come up with your final design, now try to dimension it in such a way that someone else can design everything from start to end. I mean, can produce everything, both the drawing and the 3D view from start to end without any issue. So this now, you do this as an assignment.
Okay.
You submit this. I don't know if you have this now. If you have this document.
Yes, I have it.
All right. So I'm not going to talk about this here. Then section views.
When is the deadline for submission of the assignment?
It will be communicated to you.
Okay.
Preferably before the last class. Preferably before the next class.
Oh.
Well, because you're working, let's just say within 72 hours.
Ah.
Is that okay?
Okay, let's see. Yeah.
Okay.
So sectional views. Sectional views, they're used to show the.
Sorry, in terms of the assignment, you don't mind if I use a pen because, like I'm at offshore platform. I don't have my drawing tools.
No problem. No problem. So sectional views, they're used to show the interior detail that are too complicated to show with outside and hidden views. Take this for this now. So this is how we show sectional views. You'd assume it's being sliced. The object is being sliced into two, and then we look at the hidden details. It's like this object here now. If you slice it off, if you can look, you will see the section line. The section line also has alternating long and short dashes. That's the line used to represent the sectional line, and then this is AA, section AA. Are you following?
I'm with you.
Okay. So if you slice this object now and take note of just this part here, which is this part here, this is what it will look like. So you can then properly dimension this. Since this is a solid object that is normally closed, if you dimension it without showing this section view, it might be a bit difficult to get some of these dimensions. So it's proper. You slice this. One thing to note in this section view is that some parts are hashed, some parts are not. The parts that are hashed are the parts that, if you assume something like a knife slicing through the solid object. Sorry?
I said the part you hash are the part that the cutting plane passes through.
Exactly. So the part the cutting plane touches are the parts that are hashed. Exactly. So these other parts that's like this now, this is a hollow, so it's not be hashed, which is what you see here. But you're seeing a center line here,
yes,
showing symmetry and the circular feature on all this. All right. So this is the cutting plane now, showing the sectional view. There are different types of this one you just saw now is a full sectional view. There are other types of sectional views. This is a cutting plane, arrow indicating the direction of sight, and then these are the hashed parts. So the cutting plane indicates where the imaginary cutting takes place. The end of the cutting plane line are bent at 90 and are terminated in arrowheads to indicate the direction of sight for viewing, which is what I just explained. View placed opposite to arrow direction, and subtitles are used to specify section views, which is the AA, A and A. So the section lining now, they indicate the surface that has been cut and make it stand out clearly. The thin parallel lines placed at 45 degrees to principal edges or axis of the part, and they are uniformly spaced. That's the hatching we're talking about. The hatching is usually done 45 degrees, uniformly spaced. And that's the good thing about using CAD now. It just makes all these things easier. If you're drawing all this with hand, you need 45. You need to take note of the fact that it should be 45 degrees and the space should be uniform, and doing it with hand may be a bit more challenging than doing it with the help of a computer-aided software, design software. So there's different types of section now. There's the full section. In the full section, the cutting plane extends throughout the whole object, just like it was. I said, assuming this is the object now, the cutting plane cuts through the full object. There's the half section. Now you need to look at this properly now. This is the cutting plane now. It did not go through. It cut out just half. It's cut out just half. If you can, this will help explain it properly.
Yes, I can see.
Then there's also the offset section. It allows sectioning of features that are not in a straight line. There's no. The offset section is something like this now. It can be sectioned something like it doesn't have to. The offset section doesn't have to be. It doesn't have to be full or half. So assume this is the section line. Something like this now can be is an offset section. Assuming this is the section line with the two arrowheads here and here, you can section like this now, this up and here. It's possible that there might be a circular feature here and a circular feature here, and so if you want to do full section going through, you may not capture this other circular feature. If you want to also do half, you might not capture this. So in a case like this, we might use an offset feature. You understand, right?
Yes.
Do you understand?
I understand.
All right. So dimensional lines indicated by extension lines, dimension lines, leaders, arrowheads, figures, notes, and symbols. So these are the different types of dimensioning lines. This is the arrow, or I'll just let me show you an example with a drawing now. It's one of these dimension drawing. Dimension. So these are leaders. Something like this arrow up here is what we use for a leader. The internet is a bit. It's showing me images, but something like this arrow here. I don't know if you can see the arrow I'm trying to show you. Hello?
Yes, I'm seeing it. I'm seeing it.
So this line arrow here is what we use for to represent a leader line. So all these are really just the types of dimensioning lines we use. The normal arrowheads, which is what we've been using, the leaders, their notes and symbols. So lines used are thin in contrast to the outline of the object. I'm talking about dimensioning now. The dimensioning lines are usually thin compared to the normal thick lines used to show the edges of the object now. Dimensioning lines, they must be clear and concise, permitting only one interpretation. There should be no redundant dimension. It shows the distances, the diameters, and the angles and locations. That's what we use dimensioning lines for. So there are two types of placements of dimension. There's the unidirectional. In this one now, all the nomenclatures are horizontal. If you take note of this now, look at these two. They are all horizontal. See the orientation of two. See how one is. See how this other two, even though it's dimensioning an inclined line, the nomenclature is still horizontal. It's called unidirectional. They all face one direction. But aligned, see the difference now. Are you seeing how this two is? And see how this is. So aligned now, this is it's out of date. So aligned now, the nomenclatures are aligned with a particular dimension. So since this one is dimensioning this part, so it's facing this way. So this other one, it has tilted this two. So this now we try to align the names or the dimensions with the object, but it's mostly not in use. So the line types now, dimensional lines, they denote particular sections of the object. they should be drawn parallel to the section they define, and they terminate in the arrowheads. I believe this is very
The network from
very
your
smooth.
side is a bit slow, and it's affecting your voice.
My network is a bit slow.
Coming from your end, and it's affecting your voice. I think your voice is cracking.
Oh, I'm really sorry about that. So is there any part you miss? Is there any part I should repeat? Is there any part you did not get properly? Hello?
Hello?
Can you hear me? Can you hear me?
Hello?
I can hear you. Can you hear me?
Continue. Let me see. Continue.
Okay. So I'll just repeat this a bit. I said the aligned dimensions. The difference between this and the other one and unidirectional
I'm
is
okay with this. I'm okay
okay.
with
You
that.
got this. Okay, so dimensional lines, they denote particular sections of the objects, and they should be drawn parallel and terminate in arrowheads. Extension lines, sorry. Extension lines now, they denote points or surfaces between which a dimension applies. They extend from object lines and are perpendicular to the dimensions. What do I mean by these extension lines now? These are extension lines here. These ones here. Can you see what I'm showing you? Can you see where my cursor is? Hello, are you there?
I'm there.
Can you see where my cursor is? Can you see what I'm showing you? I said these are extension lines. I don't know if you can. You're understanding me because
I can't even hear. Let me see.
There is no spoon. Is there? This is
you
not.
said you can't hear me.
This also contains that in this thing. Right.
Hello, can you hear me?
Plenty of it. The battery. What do you want to do?
Is
The other one. I used to buy all the time.
can you hear me now?
Okay, I think it's better now.
Okay, I said these are extension lines. I'm trying to show you on the screen now. Can you see where my cursor is hovering around?
Okay. I've seen it.
Okay, so I said these are extension lines and these are dimension lines. Where this two is, this is a dimension line and these are extension lines. So like I said, the extension lines are usually perpendicular to the dimension lines, and they denote points or surfaces between which a dimension applies. So line types. So these are the leaders now. This is what I was trying to show you. These are leaders. These lines are called leader lines. It can have an arrowhead or this. Can you hear me? I need to be sure you can hear me. don't know if the network. Can you hear me?